Yeah, so it's recording, yeah. So what we're going to look at is we're going to look at what we call measures of central tendency, of central tendency. And then we're going to look at measures of variability, right? Variability, that's the I, the I, yeah. Right, so we're going to look at these two things. Now let's talk a little about what we mean by measures of central tendency. Let's start. Measure of central tendency. Now, whenever we collect data in statistics, very often you will find that the data presents itself normally, meaning that the data will spread out in the shape of this curve you see here, right? And we refer to this curve as the normal curve, normal curve, right? And what this is telling you, that whenever you collect, especially collect large amounts of data, what happens is that more often than not, the, the data is going to spread out. And if you were to plot, the data against how often a particular piece of data occurs, you're going to have a shape like this. Let me give you an example of what I'm talking. If I were to take, let's say, the weights of, uh, let's say 100, the weights of the weight of 100, let me go with teenager, teenager, right? What you will find is that if you were to, okay, let's say, all right, what weight do you think a teenager will have? Like, about 60 kilogram roughly on average, 60 kg. So let's say, all right, this is 60 kilograms. What we will find is that most of this 100 of teenagers that we have, most of them, most of them is going to be very close to 60 kilograms. Right? I'm just saying this here, there's a name to it. It's called a mean, right? It's called a mean score. And we'll talk about what it really means a little later on. Right? So I'm just, you know, using an arbitrary figure, and I'm saying that teenagers are roughly about 60 kilograms in weight. Now, what you will find is that most of the teenagers in this 100, right, is going to be somewhere around 60 kilograms. Then, if you notice how let's call this axis here. So this axis is weight, right, in kilograms. This axis is the number of teenagers, number of teenagers, right? Teenagers. So if you notice, the higher number of teenagers is somewhere around 60, right? So you might have, okay, let's say this is 50. Uh, let's say, no, let's not jump so fast. Let's go with 55. Let's say this is 65. So between this little range here, most of our teenagers are going to fall, you know? And that's why you see this high frequency, um, maybe what? Let's go 100, maybe 40 of them. So go with 40 of them. No, that's so much. Maybe we'll go with 20 here and let's go with 30 here. All right? So roughly what you will find that about 20 of the teenagers might very well be around, let's say 55 kilograms or 65 kilograms, you know. Um, and the highest number, about 30, might very well be around 60 kilograms, you know. So basically the bulk, if you notice, that's 30 and 20, that's 50 people, or half of the population or the number of teenagers that we are surveying has a weight somewhere in the middle there. And then to a lesser extent, let's say a weight let me come down here. Let's say this is about let's say 40 kilograms. You would have too many teenagers being around 40 kilograms, 80 pounds. They're like a starving God's child, you know? Yeah. If I have a small number, maybe about 5 of them, it's like that. And similarly, you go over here. Let's say this is around what? 80 kilograms. That's about 140 pounds, right? You might find again, you don't find a teenager might not have this amount of weight. That's about 100 and what? 80, what, 160? Yeah. Yeah, that's about 160 pounds or 165 to 170 pounds. Few teenagers would have that kind of weight, right? And that's what you see almost in any data that you collect, right? Once you collect, if the sample is fairly large, and in statistics, when you have a sample of more than 30, you have a large sample, right? And here we're talking about 100 teenagers. So we have a big sample here. And what will happen is that if you were to plot, you know, the various weights you collect, right? And they occur, or even if you don't plot it like that. If you were to just throw all your weights on what we call a scatter diagram, right? And you put all your weights, and so you see the weights will be like something like that. That's what you'll see, right? So when you draw like a line of a curve of bend, you will have um, you will have a curve, something like that, right? And this is what we refer to as the norm. So what you want to often investigate about your data is the center around the middle of this curve. How much does the data center around here? Right? Call we're looking for measures of central tendency, right? You want to see, well, you know, how much of your data is around the middle there. That's where the bulk, you know, if you're going to, let's say, you're going to make a product, you know, or maybe the school or the ministry wants to make an intervention. You know, when they look at 100 teenagers, and let's say this number is small, you know, let's say it's 40 kilograms, they might say, you know, something for teenagers, um, they're very thin. Are they malnourished? Do we have to have some kind of intervention? Could it be that they have eating disorders, and so a lot of them, and therefore we probably have to give them some counseling and some guidance, and so, you know, so you have to know where the bulk of your information is. And that's why what we call measures of central tendency is very important in statistics. And there are three of them that we like, right? There are three of them. measure of central tendency, right? And the three that we look at is one, the mean, the mode, three, the median, right? So these are the three we look at. So let's take one of them one at a time. So maybe what I have to do, I have to get a I'll probably let me get some data. Um, give me a second. So let's say this is some data we collected, right? So we have 10 households, and again, this is not very good because it's a small sample. The small samples don't tell us much, right? It's true if you study advanced statistics and so on. They do, come up with some ways of analyzing small samples, but it's not the best thing, right? It's not the best thing, but I'm going to use it because it's going to be easy to do all the calculations we want. But whenever you're dealing with, you're collecting data, you want to collect a large sample as possible based on how much money you have to collect. The data, to collect data always costs money, right? There's so much that goes into data collection that you always have to watch costs. Okay, we're working on that. So when we talk about the mean, right? The mean, and there's a symbol for it, right? The mean is this here, right? That is the mean. Now, whenever you're looking at the mean really is the sum of all your individual data over the number of pieces of data you have. It's basically what we call the average. I don't know if you remember when we did that when we were doing arithmetic. Right? We talk about the arithmetic mean or the average. And basically, to find the mean, what we do is we add up all the individual pieces of data we have and divide by the number of pieces of data that we have. So our mean then for this set of data, it's, what is it? Number of children in 10 households. You simply add them up, 4 plus 1 plus 5 plus 4 plus 3, 7 plus 2 plus 3 plus 4 plus 1, all over 10, right? And how will you get there? Anybody adding for me? This is 10, 10 and 7, 17 and 7, 17 and 7 will be 24, 26, 29, 30, 34, 34 divided by 10, 3.4, right? Now, you're seeing an advantage here of the mean, you're seeing a disadvantage of it. One advantage of the mean is you make use of all data in its calculation, right? So every piece of data collected influences this number, right? However, you can have a value that is not very meaningful, right? Or doesn't represent one of the pieces of data inside or cannot represent a piece of data in the sample. Why I say that? We have here 3.4. Can we have 3.4 children in a household? That can. That can't happen, right? You can have 3.4 children in a household. So you see a limitation right away there um, in calculating the mean, right? So keep that in mind. You can have that problem where um, while you make use of all the data in the sample, you might have an unrealistic value of the mean, and that's a disadvantage, right? So that explains why sometimes people are reluctant to use the mean in certain things. But keep in mind this formula here, right? Keep in mind that formula. Now let's talk a little about, let me move this.
Excuse me, sir. When you add up all, you're supposed to get 31 because I get 31.
Oh, you got third one? This is 5, and this 5 is 10. 10 and 17 and 7 is 24. This and 2, 26 and 3, 29. And this is 4 here, this is 4. 29 and 4, 33, and this one, 34. It's 34. Now, the next one that is used is what we call, let's go with the median force, the median. The median. The median basically is the middle value in all these values. So for you to pick out the median, you don't calculate it as you basically, can pick it out. But before you can do that, you have to actually arrange these scores in either ascending or descending order, right? The median score is the middle one, but you can't just pick because these are all random, right? You have to arrange them. So we have, okay, we have a 1, we're going with ascending order, right? Then we have another 1, that's this one here. We got a 1, we got a 1. Then we got the 2. Any more 2s? No, we got 2 3s, right? Got a 3, we got a 3. And then they got 4 4, right? Sorry, 3 4s, 1 2 3. Yeah. The 3 and 3 6 and 2 8, and then we got a 5, and then we got a 7, right? 7. So we got 3 3 6 and 3 9 1 10. Good. So we have them there in ascending order. So we're looking for the middle one. So there are 10 of them. Now, if you had 11 of them, you'd have a nice middle one. But in this case, notice what? These 4 and these 4 are that 10. But in the middle, got 2 of them. So the middle one then, the middle score, sorry, the median happens to be not a number of itself, right? Not a number of itself, but 2 numbers is in the middle. So what we do, we add the 2, 3 plus 4 over 2. And you get, what's that, 7 over 2, 3.5, right? 3.5. Now, at times, the median usually give you a number in the data set, but in this case, because the number of numbers is an even number, in the middle here has two numbers and not 1, right? So we end up having to find the average of the 2 and we get 3.5. So again, that's another disadvantage, yeah? Right? However, do you notice that the mean was 3.4 and the median is 3.5, very close to one another, which is very good, right? That's what you want. You don't want, well, even you study statistics further, you will see why these things are important, right? I'll explain in just a moment. A little bit. I can't go into much, right? But yeah. And then another thing we want to do is we want to calculate or pick out what we call the mode. The mode. And the mode is basically, the mode is the piece of data that occurs most often, right? often. Can you pick that out from this list? Which piece of data occurs most often? Which one occurs most often? 1, 2, 3, 4, 5, or 7? Which one? Are you with me?
Four, sir.
Anybody's with me?
Four, sir.
Which
Yes,
one
sir, I'm
occurs
with
most
you.
often?
4.
4, yeah. So 4 is your mode, right? So these measures that we considered, right? We considered for this piece of data, we found the mean to be 3.4, the median to be 3.5, and the mode to be 4. And you notice the mode happens to be an actual value in the data set, right? Call it a data set or a sample, right? So the mode most often, or I should say always, will be an actual value in the data set. And that's when you deal with what you call, this is what you call discrete, a discrete variable. Number of children that households have is what we call a discrete variable, in that you can have 1.5 children, you can have 1.25 children. Whereas there's what we call a continuous variable. Like if I'm to check, we talk about weights of teenagers. That could be any value, right? You will get 60.5, another body person will get 60.9, another person will get 65.2. They can get all kinds of values, right? Any value within a certain range. You call that continuous variable. Yeah. So you see how we can actually do the mean, the median, and the mode, right? When we have a data set like this. Of course, there are situations when you have what we call a frequency distribution, or what we call a group frequency distribution. And those calculations can get a bit more complicated, right? If you look in the notes that I gave to you, you'll see how those can actually get a little more complicated to calculate, right? But we're going to stick with the situation where you just have a discrete or sorry, the individual data in the data set, right? You're going to be given a sample or maybe a complete population, right? Where the data, each individual pieces of data is going to be given to you, right? For you to get into frequency distribution and group frequency distribution and so on, that will call for you gotta get more time. You can have 2 hours to learn all of that, right?
Excuse
The
me, sir.
notes have two
You
examples.
send notes in the
Uh,
model group?
yes, yes. I released some notes today. So you will see the notes have calculations that involve frequency distribution, group frequency distributions, and so on. And those can be rather complex, right? But I'm going to stick with when you're given all the individual pieces of data, right? I'm not going to give you a very, very large sum. I'm going to give you a smallish sum, right? And, well, you can be able to calculate the mean, mode, median, and so on from that, right? Cool. So we talked about the mean, the mode, the median. Let's talk a little about measures of measures of variability, right? Measures of variability. And what you're going to do here is, or what you're looking at here is how spread out. So we talked about that normal curve, right? So sometimes you can have a normal curve looking like that, right? Let me see if I can. Let me erase it. How yeah. So you can have, okay, a nice normal curve like that. But then you can have a situation where you have this. You might have this. Right? You might have that. So, oh, I should use a different color there. Let's see if I can use two different colors. Right, I go with a black forest. So you can have a situation, a nice normal curve like that. And then you can very well have a situation of so what you see here is that this data, the one in the black, is more spread out. Let me use the word spread out. While the red is kind of concentrated in the middle here more, right? See? So what you have is that these two, the variability of the two sets of data now is very different. This one, the black one, is more spread out, while the red one is more concentrated, right? In the center. You see? So that's what measures of variability is all about. How spread out is the data, right? And what we look at basically, we look at some very basic ones. We talk about what we call the range, right? And then we'll talk about two things. They're very related. What we call the variance, but we mostly want to talk about something called the standard deviation, right? These two we want to talk about, right? We want to talk about range, and then we want to talk about variance of it, right? What do we mean by it? Let's see if we can get a data set. You know what? We can do that. I have to stop sharing for a moment, right? Let me stop sharing for a moment. And yeah, so yeah, when we talk about measures of variability, well, they use the word variation. See the very two curves I was talking about. So we look at range, variance, standard deviation, not so much coefficient of variation, but you know, touching it, right? Yeah. So these are what we're going to look at, right? They help us to tell us how spread out data is. So let's start with one at a time. The range. So when you speak of the range, what are we talking? Right? Simply put, it's basically the difference between the largest and smallest values in the data set, right? As it says here, it's the simplest thing to see and calculate, right? But notice this is more of a disadvantage because it says is very sensitive to those extreme values, the smallest and largest values. Because what could happen, right? What could happen is that you can have a situation where, you might have a test, right? And let's say you have a test. Students got like, okay, 4, 5, 6, 7, 8, 8, maybe, 8. And then one student gets a 0. Or not a 0, let's say 1, right? And makes the range, because the range now is the difference between the 8 minus 1, which is 7. And this kind of tell you that, okay, that this class here, they have students with a lot of, we call variability, or say students of very varying abilities in this class, right? But that's not really true, because the majority of the students are around this let me say the 6 mark here, right? Or this 7. They're not very far from the middle here, right? It's just this one student that is making the thing look like that. Because if you were to just disregard this one, right? I'm not saying you throw the one student out of the class, but basically the range would be from 4 to 8, which is 8 minus 4, which is 4. And that should tell you, what? That most of the students in this class are around the same ability, And that, let's say you're a teacher and you see the range of scores is very large, it means that the children in the class, that they have very varied ability. But if the range is very small, everybody doing around the same, when you check their scores in a test, and most of them are around the same score, and you know, that's a situation where, most people they have around the same ability, You see, if you know the abilities of students in your class, you will know how to teach. If you don't know that, well, or you don't consider it, you can be very well leaving people behind, you could also not challenge them at all, and that sort of thing, right? So we talked a little there about how you measure, um, how you measure measure it, but here's a little reminder here. You subtract the smallest piece of data, right, from the larger, right? And you can see an example here, right? So you have a set of data, right? And this is telling you that let's say these are scores in I should say what, 1 to 14. Let's say there's scores in a test out of 20. So what this is telling you, one student scored 1, right? The number of counters up here, like guys, like one student score 1. One student score, this is a little more than 2. Let me put it 2. 2 students score 4 and so on. But the lowest score is 1 and the highest score is 13. So the range is going to be the difference of the two, right? And as I mentioned, there are disadvantages and advantages of that, right? You're seeing that in this example here, right? So yeah, that what it does is that it ignores the way in which data are distributed, right? And it's sensitive to outliers. We just talked about that, right? Those are some disadvantages of it, right? We have an example here. Let me give you an example. Oh, no, that's not better. So, give me a second, let me grab this example. All right, look at this. Right? So you have a whole data set here. I don't know what it is. They didn't see what it is. Right? And basically, if you want to find the range, well, in this case, they actually arrange the data from lowest to highest, right? And from that, now you can pick out the two and subtract. Okay? You're following so far?
Yes,
Then
sir.
there are some other ranges that they talk about, right? And we're not going to get into them. I'm going to give you some notes on them. They have what you call the interquartile range, interquartile range. And then there's the semi-interquartile range, right? So there's the interquartile range, there's the semi-interquartile range. And what these really involve, right, is that you take all the data and you break it up into 4 parts, right? So this is one part, this is the fourth quartile, this is the second quartile, this is the third quartile, this is the fourth quartile. Bigger 4 parts, right? 4 parts, 1, 2, 3, 4, right? And the interquartile range is this score here, or this piece of data, minus this, or the other way around, right? It's this, you call this Q1, Q2, and this is Q3. The interquartile range is Q3 minus Q1. Right? The second quartile, the score is actually the median. It's actually the median. And the semi-interquartile range is simply the interquartile range divided by 2. Right? And very related to this is something called there's something called percentile. 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 Right? I don't know if you ever heard people, some relative of yours, and so they write those tests out there, like what they call SATs or GRE exam. You ever heard of these exams? SAT, you're supposed to hear about this. Ever heard of that one? GRE, you write to get into, universities that, if you want to do postgraduate studies. SAT, you write to get into college and so, to get scholarship and so, right? The standardized exam they have out there. And students will say, well, I'm in the 90th percentile. 90th percentile. What that student means is that they performed better than more than 90% of the students. If somebody say they are in the 60th percentile, they mean that they have performed better than more than 60% of students. Right? That's what it is. Right? But remember this, we can in 2 hours deal with all of this. We got a whole course, right? To deal with those things. Just as an example, talk about the quartile range there. I'll show this up here. And with this data, because it's a range from lowest to highest, you can pick out the Q3 score, the Q1 score, and the difference of the two will be the interquartile range. As I said, the semi-interquartile range will be half of that, which is 40, right? Good. Now, we're more concerned with the variance, and more so the what we call the standard deviation, right, of a data set. Right, so this is the reason. The reason is spelled out there. Why variance and the standard deviation is so valuable. Very much like the mean, it makes use of all the data in its calculation. Right? That's a plus for it. Right? And let's say when they're telling you the based on the difference between the value of each observation and the mean, right? Well, they're telling you the two symbols here. This is the mean for a sample, and this is the mean for a population. I don't worry that so much. How do we calculate? How do we calculate the variance? Here's a formula. If you were to have, right? You have a large population, you can collect the data for the whole population, but you're just taking a small sample. Usually in statistics, you say you're taking a representative sample. So this is the formula to calculate it, right? Please note in the denominator here, there is an n minus 1. Because when you come to what we call population variance just now, you'll see it doesn't have the minus 1 inside. So in the calculation of the variance, what you basically do is you take each individual piece of data and you minus the mean from it. And then you take that number and you square it, and then you add all of them up. So it's a lot of work. It's a lot of work. And mind you, I don't expect that you to ever use your hand to do this, right? These days, we have very powerful computer programs, such as SPSS. Excel can do it. There's a program called R that can do all these things very, very quickly, right? Gone are the days when you take a pen and paper and calculator and do this kind of thing, right? Let me just give you the population variance, right? This is what that looks like. Same thing, but the only difference is the n at the bottom there, right? N at the bottom there. Notice the symbol for the population variance is S, right? Usually for the sample variance is S, but for the population variance is, this is common sigma, right? Common sigma. Right? It's a common letter for this letter here. And then out of the variance, right? Out of the variance, we now have what we call the standard deviation, right? Standard deviation. And basically what the standard deviation is the square root of the variance. That's all. That's the only difference. It's the square root of the variance. And a plus for us is that it has the same unit as the data you're collecting. So if you're collecting people's weight, the standard deviation is going to be stated in the same unit, weights, kilograms, right? So that's the advantage of it. And the formula, and if you're dealing with a sample, this is the formula you use. right? That's the formula there. If you're dealing with a population, if you got a whole population, right? You're gonna change this to, right? And you're gonna take out this one from here. If you're dealing with a population. But when you're dealing with a sample, well, you have to have that -1. There's reasoning behind it to, high for you now. If you study statistics on, you're going to be able to understand those things.
Some peas with
Chicken, hot it up. Hot it up.
So as an example, we're going to do a very, very simple example, right?
hard.
All right, somebody got to mute their mic, the microphone there.
What you gonna do, man? What you gonna just do? I'm not too sure. Sir?
You press the button?
Yeah, you gotta mute yourself, right?
Sir, you could unmute it because my son end up holding the vehicle on it. If it's me you're hearing, if you can unmute it for me, please. Unmute it now.
All right. Yeah, good. So this is an example of how it's calculated. I notice we're giving a very small sample, right? We're giving a small sample. So remember we talked about how to calculate the mean already. You add up all of these, and there seems to be 8 pieces there. 1, 2, 3, 4, 5, 6, 7, 8 here. You add up all and divide by 8 and you get 16, right? So what you do, you take each value, 10 minus, you have to put 16 here, 12 minus 16, 14 minus 16, and so on, right up to 4 minus 16. Square each of these numbers. 10 minus 16, that is 6. 6 square. You do that. That's what you do here, you see. And when you finish all of that, you add them up. Looks like you will get 130. You can always do this in your spare time to show that, well, you follow what's going on. And divide by 8 minus 1, because you have 8 pieces of data in the data set, right? Notice this is a sample, right? If you deal with a population, right? So this is a simple example of how you calculate the standard deviation for a Now, here is where we go to a higher level of statistical analysis, right? Where we want to kind of interpret now. We want to interpret what the standard deviation is telling us. What is it telling us, right? So whenever you see your standard deviation, look here, we got 3 values. We got one standard deviation is 3.338, one is 0.926, and another one is 4.57. And what you're seeing is that whenever you see a standard deviation is a large number, like this one here, or this one here, it's kind of telling you that, you know what, your data is too spread out, right? The data is too spread out. But when you have a nice small standard deviation like that, well, then you have more like a bell-shaped curve. All like this. This one look like this. This one look like this. This is more like a normal distribution. That's why it has a smaller standard deviation, right? And I think I did we did do an example one of the days. I was telling you a story. If I were to go, now we were talking about, let's say you're working with the Bureau of Standards, right? And you get complaints, and maybe you can go to the factory of somewhere that makes, let's say, drink. Right? And the standard deviation is equal to, let's say, a quarter of a liter. Oh my, what's happening? Yeah, a quarter of a liter. Now, this is a big amount, right? That's a large amount. That means that they got some drinks in that batch that would actually be 3/4 of a liter. People getting robbed, right? People getting robbed. It definitely can be a quarter more than a liter. It wouldn't fit in the bottle, right? So you talk about maybe lots of times the situation is that the drink is very less than 1 liter, and you might have to, get the owner to adjust the machine that is filling the bottle, right? So yeah, the standard deviation is something that we want to pay attention to because it tells us how much deviation from the mean there is, right? And that can be very useful, right? Can be very useful. Lastly, we want to talk briefly about what we call, well, you know what? Let's not get into this one. Yeah, this one has to do with coefficient of variation. It's basically, let me throw it up here quickly. Yeah. It's just a standard deviation over the mean times 100%, right? That's what it is. And again, you don't want that to be too large. You want it to be very small. The smaller your coefficient of variation, right? The more, your data is more concentrated around the center, right? Or around the mean of all the data. And that's what you want to happen, right? So, I'll make available these notes on your Moodle page, so you can get to read them at your own pace and so, right? But with that, I don't want, because this is not a full-fledged course in statistics. It's just a little bit to get your foot wet, right? In basic statistics. So just remember, we talked about measures of central tendency, right? And we talked about the mean, the mode, and the median. And then we talk about measures of variability. Right? And we talked a little bit about a number of types of ranges, right? We talk about the simple range and then interquartile range and all of that, right? And we focus more on what we call the variance, and then the standard deviation, which is simply the square root of the variance, right? And its significance is very important in statistics, right? That kind of gets you, a little bit of familiar with some basics in statistics, right?